Hello, my name is John Gabriel and this is the New Calculus channel. Today I'll be talking about the rot known as real numbers and Cauchy sequences. So I happened to turn to this article by one Marianne Freiberger, a real idiot, but in any case, she says, what are the real numbers? And perhaps the most intuitive answer, wow. Now, please stop right now and look up the word intuition in your dictionary, is that they are all points you can find on the number line. Really? Points have no dimension or extent. Now, let me tell you, I have often come across graduates, people who've done a course in mathematics who had been brainwashed with all this bullshit. But in any case, what struck me about this article is how she and all her colleagues believe that Cauchy sequences uh, would be a good way to construct a valid formulation of numbers. In fact, it's anything but. So let me get to my article, which I've written, and I'll place a link to both this and her webpage in the details section. So what I really want to talk about are what are positional value systems. Well, they're known by many names: positional value, place value, decimal number system, radix, base representation, etc. The list goes on and on and on, but what it tells us very clearly is that mainstream academics are clueless about measure and the number concept. So you can know that the Elements was an attempt to well define the number concept. Euclid almost got it, but I completed the job for him. And you can read all about how we got numbers at my famous world famous article at this link. I detail not only the meaning but the history of number. So now let's get back to the part of place value systems. Why did people even adopt Stevin's decimal system? Well, unfortunately, arithmetic with fractions is very hard when one has no clue what it means to be a number. You see, numbers are fractions. Really, all numbers are fractions. There is no exception. There is no such thing as an irrational number, okay? When we talk about number, we're talking about rational or reason or ratio or logos, okay? Not alogos, but logos, which means reason, rational, okay? Mainstream teachers are like the blind, or not like the blind, they are the blind leading the blind. So what were the main goals of Stevens de Tiende? Well, you can see four main goals here: expressing numbers easily without the use of fractions, because teaching fractions was always difficult for math educators, or miseducators rather. A means of comparing numbers easily, performing basic arithmetic if we know a recipe, which we can learn in rote fashion, and also a means of identifying numbers uniquely. Very important. And this is one of the most important reasons of decimal number systems. So now I've just created this theorem, by the way. Given any radix system B, there might be some equivalent out there. I don't know, and it doesn't matter. It is true that only the digits 0 through B minus 1 are required to represent measure uniquely in base B, okay, where a template is described by what you see here. So you have a template with the powers, the integral powers, by the way, of base B. And it must be understood that the said representation, this representation, may not always be possible, okay? Even with rational numbers in a certain base, you may not be able to express them. A good example of this is 1/3 in base 10. You cannot write 0.333 ... because it is not a representation of 1/3 in base 10. You fucking mainstream morons, okay? Get it? Right, maybe not. So let's see a simple proof of this theorem. And a simple proof is very easy, as you see over here. So if you assume that there are coefficients a1 and a2 and also a3 and a4, then what you can do is reason as follows. You need this to be equal to this, but it would be impossible if a1 is not equal to a3 and a2 is not equal to a4, because the base factors 10 and 1 remain the same. Therefore, by transitivity of equality, a1 must equal to a3 and a2 to a4. And so I've shown you just with integral values that the representation of measure is unique. If you have the energy, go and do the same thing for the fractional part, but you really don't have to. Now, you can write the number 1 in only one way using any radix systems. That is as follows, because it's base b to the 0, okay? And we can prove that any base to the 0 is 1. Now, you cannot write it as 0.99999 as you see here, because 1 is not equal to this thing on the right, okay? It's equal to the limit of this thing on the right, which is not the same thing, okay? So this here is a series. It's not a number. It is not a number after one term, after two terms, after three terms, after infinitely many terms. Really? Infinitely many terms? Think about it, you idiots. Think about it. Do you have infinitely many terms? Please think about it. No, we're not going to do what Euler did and say that S is equal to lim S, because we cause problems, right? And let's see what kind of problems. Well, suppose we have to begin to compare numbers. In the decimal system or any radix system, we look at the leftmost digits, and all we need to look at is 1 and 0. 1 is greater than 0, right? So that would supposedly imply that 1 is greater than this thing here, which isn't even a number, okay? I don't care that Euler defined it as a number. Euler was wrong, okay? He wasn't thinking properly, just like most of you are not thinking properly. So this is not actually a number, but shorthand for this series, all right? So if we do what he did, we lose the property of uniqueness, okay, which is an important reason for adopting radix systems. The problem we want to get away from equivalent fractions is that in order to do arithmetic with them, we have to constantly convert them into the same denomination, okay? So which one of these is true? Only one of them is true, right? So, and to determine which is true, we have to make them have the same basis so that we know what we're talking about, right? And by the way, equivalent fractions are based directly on the theory of similar triangles and the proportion of their sides, right? Okay, I'm not going to go into that. That's not the purpose. So we lose the very property that we wish to rid ourselves, which states that 1/9 is equal to 2/18. And of any other enumerable representations, as you see here on the right, 1/9 times k over k. So comparing 0.25 and 0.24999 means you have to introduce a new mechanism which now requires an inference of limit from the right and not the simple leftmost digit comparison. So as usual, mainstream academics have their heads way up their arses. The baboons want you to believe in infinite sums. Somehow, on completion of the limiting process, which is just a disguise for infinite sum, a magical carry occurs. Oh, it's interesting that this stupid bitch who wrote this article talked about carry as well. And let's look here. Carry, yeah, she says that's because the pesky carry operation. That's because of the pesky carry operation. So she says you can't just assume the nth digit in the decimal expansion of pi plus square root 2 is the sum of the nth digit in a decimal operation. That's right, you moron. That's why decimal systems were designed. Do you understand that? Okay. Wow. All right. So The baboons don't even realize that they break the entire arithmetic of radix systems. They introduce absurd concepts such as this, which is a phantom number that causes the carry. So if we write 0.25 is equal to this that you see on the right, this here is in fact a valid Cauchy sequence. It's this sequence here. And if you don't believe me, idiot, find the common ratio between these terms. Okay? Now, equivalence classes of Cauchy sequences do not define real numbers because all of these here are representative of 0. What did they tell you about the measure of 0? Nothing. Just as this here tells you nothing about the measure of 1. Okay? Even the definition of Cauchy sequence is obfuscated. It's misspelled obfuscated, never mind. So the above is a property of any converging sequence, meaning it has a limit. So to use this definition is in fact circular. You cannot use something that is circular. Ask yourself how any of the fucking mainstream morons could know this property if they did not already know a limit exists. There is even an invisible assumption in this definition that a convergent sequence has a limit, because the property is in fact a theorem from convergent sequences. Okay? So in many cases, it is not possible to conclude that a given sequence is convergent simply from checking the knowledge of the sequence, as this statement says. It's not enough. So if I had to give you this sequence here, there is no way you could check from it that it converges. All right? Because if you didn't already know about pi, you would have no clue how to start checking. Do you get it, morons? Refusing to accept correction is the first sign of a crank. Mainstream mathematicians are cranks. Okay, so radix systems were introduced to simplify arithmetic. But what did the orangutans do? They obfuscated things. In no science or application do we ever use anything besides the rational numbers. Even in Fourier series and the so-called complex number theories, we do not use anything but rational numbers. Do you get it, morons? Wow. Okay, so Steven knew that even a given radix system could not represent all numbers, but assumed that an approximation would work fine in any application. And of course, when he wrote his book, he had astrologers and gamblers in mind. And now, why do brokers on the stock exchange talk about a third or 2 sixes? Because these describe exact measurement. All right? So, you know, I'm running out of time now. I have a limit on this of 15 minutes, so I'll have to stop soon. Be sure to subscribe to my channel, to download my free ebook, to read my articles, and to spread the news of what I'm telling you, because I am the greatest mathematician. There is no delusion about that. It's a fact, okay? I do not suffer from delusional disorder. Actually, most of the moron mainstream suffer from delusional disorder. Those fucking fools who call themselves professors of mathematics and don't know shit about mathematics. All right? Well, okay, so this video is definitely not for those who don't like foul language. But in any case, I got carried away. This is the New Calculus channel. My name is John Gabriel. Till next time, friends. Goodbye.